Okay guys, so let's start 6.14 question for exercise Haloalkane and Haloarene. The question is, write the structure of major organic product in each of the following reactions. So these are the 8 reactions given to you. So you are supposed to guess the product. The previous questions what we have done, normally they were asked how you will convert this one. They have already given you what you're supposed to do, but just you want to guess the product. So these are the 8 questions. Let's start one by one. The first question is CH3, CH2, CH2Cl, which is 1-chloropropane. They are treating with sodium iodide in presence of acetone. By seeing the reaction, you can predict that this reaction is NaI and acetone is written. It is a Finkelstein reaction, right? And Finkelstein reaction, what we do is normally we remove this halogen and we do the halogen exchange. This will go that side, this will go that side. So your product will be CH3, CH2, CH2I plus Na will go with Cl. So your product is 1-iodopropane. Khalas. Next is CH3 thrice CBr plus KOH and in presence of alcohol. By seeing KOH and alcohol, you can see this is an elimination reaction, right? So CH3, let me show you how exactly it will happen. The exactly structure of this CH3 CCBr is like this, right? So what will happen? This is a halogen, this is alpha carbon, these are the 2 beta carbon, both the beta carbons are same. So let us use this beta carbon. Can you see this HBr? Elimination means elimination will happen. So one bond will come there, one bond will come there, and you will get the product CH3C double bond CH2 and then again a CH3. 2-methyl propene will get formed. Okay, so you see 1,2,2-methyl propene is the structure along with KBr minus KBr and H2. Okay. Next is CH3, CH, Br, CH2, CH3. This Br means this Br is actually present here as a branch because the meaning of this bracket. NaOH in presence of water. If you see there is a base, there is no alcohol, there is aqueous substance here, the water. That means here nucleophilic substitution will happen. Just you have to replace the Br with OH. So the product will be CH3, CH, branch OH, CH2 and CH3. So this is your product. So if you try to number it 1, 2, 3, 4. So butane 2-ol is your main product. NaBr plus H2O will come out as a byproduct. Next CH3 CH2Br plus KCN aqueous ethanol. By seeing it again, you can see carbon. There are 2 carbons over here. KCN normally we use to add a carbon in it, and after that they are not doing anything. So what you are supposed to do is again directly you have to just remove the Br and you have to introduce the CN here. It's kind of a nucleophilic substitution again. So CH3, CH2 and CN, propane nitrile. This will be your final product. So I hope first, second, third, fourth, again we will do a quick revision. The first one is Finkelstein reaction, just you have to exchange the halogen. Second one is elimination, remove the one hydrogen from beta carbon and halogen. Dehydrohalogenation also we call it as, and you'll get a alkene over here. Next is NaOH in presence of water. Directly you have to do the nucleophilic substitution. KCN also you have to do nucleophilic substitution, remove the halogen, and you have to add the CN group. Moving on to the next. C6H5ONA plus C2H5Cl. If you see this very carefully, this is sodium phenoxide plus ethyl chloride. This is Williamson synthesis. Even though this name we have not heard in this chapter, but what you are supposed to do here is from Na and here, can you see NaCl? Whatever left behind, just combine them. So C6H5 oxygen as it is. Oxygen was having negative charge and sodium was having positive charge. Cl has a negative charge and Na was having positive charge. And C2H5 will combine here. Khalas. What you will get here is phenotol, a very important name. Phenotol. C6H5O is kind of a ether. Okay, ROR. Moving on, CH3, CH2, CH2OH plus SOCl. This is very easy. You know that this is alcohol, this is thionyl chloride, best method to prepare haloalkane. So just directly introduce CH3, CH2, CH2Cl and HCl and SO2 which will form here is the gaseous product. You will get a pure product here, the best method. Moving on, CH3, CH2, CH double bond, CH2 plus HBr in presence of peroxide. You can see here by seeing peroxide that it is anti-peroxide Kharash effect. So the halogen will come to the carbon having more hydrogen, right? So you'll get here CH3, CH2, CH2, CH2 and Br, 1-bromobutane. So anti-Markovnikov rule you will apply here. Hydrogen peroxide, anti-Markovnikov rule. Okay. Moving on here, again same alkene is there and presence of HBr, but there is no peroxide, so you will apply here Markovnikov rule. So directly what you will do here, wherever there is a double bond and carbon having less hydrogen will get the halogen or the negative part. So CH3, CH2, C, CH3, CH3, these are the two CH3s, and here double bond will break. What having less hydrogen, this carbon is having less hydrogen, so bromine will come here. 2-bromo 2-methyl butane is your answer. So again I will do a quick revision. So this was C2H5 Williamson synthesis. This will heard it the name in the next few chapters, but you have to do simple thing here. Here sodium is positive, chlorine is negative. Give both of them whatever left behind, just combine them. A phenol product will form. CH3, CH2, CH2, SOCl2, best method to remove OH and introduce Cl in it. Then this is anti-Markovnikov and this is Markovnikov. Thank you.